you see here, we have three types of muscle tissue. Um, the visceral or the smooth muscle tissue, the cardiac, and the skeletal. The visceral, it's more in organs and blood vessels, and their contractions are involuntary. The cardiac, it's found in the heart alone, and it's also involuntary. With the skeletal muscle tissue, um, they are found attached to the bones, and their contractions are voluntary. Um, from the types of muscle tissues, you can see that smooth muscle tissues, they are spindle-shaped, uninucleate, and they have no striations. The cardiac muscle cells, though they have branching chains of cells in their uni or binucleate, and they have striations on them. The uni or binucleate meaning that they have more than one nucleus per cardiac muscle cell. The skeletal muscle cells, they're long cylindrical shaped cells, and they're multinucleate. They also contain striations. With these three types of muscle cells, these are major when it comes to your muscles and how you move, and each of the striations and the intercalated disc of the cardiac muscle cells, and the smooth and shape of smooth muscles or visceral muscle cells, they all serve a purpose, and we'll discuss this in the next slide. Muscle cells, as you can see here, they have no striations, no sarcomeres. They contain actin, myosin proteins, thick and thin filaments. And these thin filaments of the smooth muscle cells are anchored by dense bodies. These dense bodies are analogous to the Z disc of the striated cells, like that are found in cardiac and skeletal muscle cells. Okay, so next question is, how do they contract? Well, you have the calcium ions that pass through open calcium channels, and these ions, they're released from the sarcoplasmic reticulum and binds to the protein called calmodulin. They activate an enzyme, myosin kinase, and phosphorylate myosin heads. That means that they convert the ATP to ADP and P1, and that P1 attaches to the head. It disconnects from it and attaches to the head of the myosin. These heads then attach to the actin that binds the sites and pulls on the thin filaments. Thin slides past the thin filaments slide past the thick filaments, and they pull on the dense bodies. In this entire arrangement, it causes the muscle fibers to contract, like you see in the picture here. Smooth muscles, they have intercalated disc, and within these discs are gap junctions and desmosomes. Now, gap junctions, they form the channels between adjacent cardiac muscle fibers, and they allow for depolarization current to flow from one cardiac muscle cell to the next. This allows for quick transmission and action potential and the coordinated contraction of the entire heart. Desmosomes are cell structures that they anchor the ends of the cardiac muscle fibers together, and the cells, they do not pull apart during the stress of individual fiber contraction. Um, the cardiac muscles have pacemaker cells that directly control the heart rate. They are self-excitable and able to depolarize and to threshold and fire action potentials of their own. And this is called autorhythmicity. We're going to talk about how skeletal muscles contract. Well, basically, it depends. It contracts as a whole, but it depends on the contraction of individual skeletal muscle cells. Uh, Either the individual muscle cell will contract or it will not contract, and this is referred to as an all or none response. Because of the number, it consists of a number of individual muscle cells. The contractions on the whole can vary. The different degree of contractions that can occur within a whole muscle results in graded responses to different degrees of stimuli. It is achieved in one of two ways, either changing the frequency of the stimulation or changing the number of muscle cells that are stimulated to contract. And these contractions of the skeletal muscles, they result from the impulse delivered to them from the nerves. They're normally delivered at a high frequency, and they um, result in a phenomenon that's called tetanus. If only a single impulse or stimulus is delivered to a muscle for a contraction, it occurs quickly followed by the relaxation of the muscle. This is called the muscle twitch. If many impulses or stimuli are delivered to the muscle contracts. But it does have time to relax before it contracts again. And this is what is actually called the tetanus that I just talked about. Um, if the frequency of the stimulation permits the muscle to relax to even a slight degree between contractions, the tetanus is unfused, or what they say, incomplete. If the frequency is high or so high that the relaxation does not occur during the contraction, the tetanus is fused or called complete. The ability to produce smooth muscles, to produce smooth and sustained movements when we use our muscles is the result of this tetanus, the time that it takes to contract, for the muscle to contract and relax again before it contracts again. And as with all contractions, you would know that calcium ions, they play a key role when determining when a contraction occurs. So when the calcium ions is concentrated in the sarcoplasmic reticulum, which surrounds the myofibrils, like the sleeve. Yeah, so the sleeve of your shirt on your arm. When that nerve impulse arrives at the muscle cell, it contracts and spreads throughout the muscle cells and causes the channels of the membrane of the sarcoplasmic reticulum to open. And all these calcium ions, they rush out and down its concentration gradient. So it depends, like I said, those two degrees of contraction, the graded responses. So it's either your frequency of stimulation or the number of muscle cells that are stimulated. This can be from the calcium ions that actually flow, rush down the reticulum, the sarcoplasmic reticulum, down the gradient, down its concentrated gradient. So if its frequency is high, and it's going to issue a response that is that is going to issue a contraction response, um, or the amount of muscle cells that it actually stimulates. This can cause the stimuli to have a different degree. So if a small number of muscle cells are stimulated, that probably all or none response will come in. Either you're not going to get the amount of, how am I going to put this? Um, you're not going to get that amount of needed stimuli for it to actually contract. It's just going to pass down the gradient and dwindle away. But if you have a high frequency of stimulation, that means that it's being stimulated a lot, uh, you're going to get that all response, the part where it's going to contract and there's nothing you can do about it. This is what I wanted to share with you about how the skeletal muscle contracts based on calcium ions, and where does the sarcoplasmic reticulum come into play. Um, yeah. Right. So this slide is actually just to show you a brief breakdown of the anatomy of a muscle fiber. Not really a muscle fiber, but of the entire muscle. As you can see from this picture, they're taking a section from the biceps and breaking it down. So the outside of the bicep muscle, you will see the epimysium, that's the covering of the whole muscle. Inside of that covering, you'll see the fascicles. Each of these fascicles, when it's pulled out, contain muscle fibers, individual muscle fibers. So there are thousands of them in a fascicle, and there are a lot of fascicles within the muscle. Um, but when you pull out one fascicle, you see it's covered by a perimysium. These contain the muscle fibers, and you could see the striations on these skeletal muscle fibers in the picture, the nucleus, the sarcoplasmic reticulum that produces the the proteins, calcium ions, the thin filaments, mitochondrion, the myosin. Remember the myosin heads that I was talking about to explain how smooth muscle cells actually contract. So yes, they contain all of these things. I just wanted to show um, a little deeper of how the inside of the muscle looks. All right, Duchenne muscular dystrophy. This is a genetic disorder characterized by progressive muscle degeneration and weakness. This is one of 9 types of muscular dystrophy, and it is caused by an absence of the protein dystrophin. This protein helps keep muscle cells intact, and lack of it can cause the cells to become fragile and easily damaged. Symptoms in this can be seen as early as age 3, and you have females as being the carriers of Duchenne muscular dystrophy. They are seen as carriers when one dystrophin gene is a normal dystrophin gene is on a X chromosome, and they have an abnormal dystrophin gene on the next chromosome, next X chromosome. So there is research ongoing that are actively pursuing several exciting strategies in this Duchenne's muscular dystrophy. So the one that I actually very interested in following would be gene therapy. They have myostatin inhibitors that promote muscle growth. The protein myostatin Um, it blocks it against um, growth signals that maintain the muscle at a reasonable size. And these myostatin inhibitors stop this from doing that. This allows for the muscles to grow larger and stronger. So this is one. And there are several um, labs that are involved in clinical trials. You have PFIZER, I'm guessing it's Pfizer. Yeah, they are in their clinical trials. And then you have Kristal Musgrove. They're in the phase to determine the safety of these myostatin inhibitors in Duchenne muscular disorder boys. Another unique strategy that I saw was um, inducing follistatin. It actually does the opposite. So it blocks the myostatin, but introducing the follistatin, it's naturally, um, it's, I feel like it's more safer because it's a natural occurring inhibitor of myostatin in the body already. And they're just introducing more of this protein into the body. Um, and there's Milo Biotechnology. They're in their clinical stage of phase one of this. There's also some other strategies like exon skipping. And if I could explain this in a way where you can understand, it's like I'll use this example. When you have a sentence, all three-letter words, and you cut out three of those three-letter words, but what is left still is readable. Um, that is, you're skipping basically the gene, because if it deletes, it's a perfect deletion. But if you delete, let's say, um, two words and a letter from the third word, and then you just put everything back together and make sure it's in threes, you still have your three words. The sentence would not make sense. So what the exon skipping will do is it will delete what needs to be deleted, remove that, and just skip over that portion. So it reads past the the absence of this dystrophin. So it would not. I want to thank you for watching this presentation, and hopefully I could leave you with some encouraging words. As we can see that Duchenne muscular dystrophy is still a disorder that is strong amongst us. We are improving because, as you can see from my last slide, teens were the furthest these boys could have gotten. And we actually have persons now living with this disorder until 40, 50 years of age. And it is due to the hard work of the scientists that are researching ways that we can either lessen the effect of DMD, or I'm hoping they eliminate it completely. But I would like to leave you with some encouragement, because if you are somebody who are pursuing research in a medical field. Um, it's Proverbs 17:22 that says, "A joyful heart is a good medicine, but a crushed spirit dries up the bones." So I want you to stay encouraged and know that you will you will find a way to get what you need to get out of life. You are here for a purpose, and Romans 8:28 says, "And we know that for those who love God, all things work together for good, for those who are called according to His purpose." And for those that are working on making the lives of these boys better for Duchenne muscular disorder, you have a purpose, and it is a great one, to give them a longer life, an active life, a life that they were meant to have. Um, and for those with this disease, I would say that Romans 8, verse 18 says that, "For I consider the sufferings of this present time are not worth comparing the glory that is to be revealed to us." Um, there is something greater. We have something great to look forward to, whether it be whether you think that it is a breakthrough in this gene therapy or gene repair for this Duchenne muscular disorder, or the end times. Um, like you say, the glory that is, it will be revealed to us. And once you follow your path, the path that God has opened up for you, follow in His footsteps, keep Him close, be a friend of Jesus. And like He says, the glory will be revealed unto you. Uh, Sufferings of the present is nothing compared to all the joy and the glory that we will see in the end. And I just wanted to leave that with you. And thank you again for watching my presentation.